project uses the H-Flights package by Hadley Wickham, and this is available at this website. You can also use the install.packages function on R. Which is what I used. I left it out of my R Markdown because it causes some errors sometimes when you use install packages in R Markdown. If your mirroring options aren't set, there is a way to set your mirroring options manually, but I didn't want to mess too much with my RStudio for fear that it would crash or that my entire computer would crash. So I left it as is, but I did use install packages, then use library H-Flights to load it up. So I wanted to compare two variables, distance and arrival delay. I thought that there would be some sort of connection between these two. Notably that a longer distance might mean a larger arrival delay. So I used subset to divide the data into arrival delays greater than 0, meaning it was late, arrival delays less than 0, meaning the flight arrived early, or if the arrival delay equals 0, that means it arrived on time. So the question, is a long distance flight likely to cause a delay? One way I decided to look at that is by using a correlation matrix. You can use COR is the R function to create a correlation matrix. Two variables I use were distance and arrival delay, and it shows a correlation of negative, and this is a pretty small number, so it is a very slight negative correlation, meaning as one goes up, the other is going to go down. So a longer distance would actually have a shorter arrival delay. And then I want to compare, like I said, late arrivals, early arrivals, and on-time arrivals. So visually, I use density plots, and if you look at the three for late, early, and on time, they're actually quite similar. So the density plots don't really lend much support for the the difference in arrival time for different distances. Then I used the summary function to get things like the minimum, the quartiles, the medians, the means for each separate one. For totals for early, on time, and late, you'll see that the means are pretty similar all throughout. So again, this doesn't really support my original hypothesis, but I performed a two-sample t-test. That's the function is t.test, and the results from this do give me a 95% confidence interval for the true difference in means between early and late arrivals. So there is some sort of difference between early arrivals and late arrivals in terms of the distance. So my conclusion is that while there is a slight negative correlation between the two, meaning a longer distance would cause that should be lesser delay, there does not seem to be any other supporting statistics or graphics to be able to concretely draw this conclusion. So my hypothesis remains unproven. That's my R project. Thank you.